All right, hello everybody. Today we're going to cover up the things on the test that hasn't been covered by the quizzes. So these are typically the word problems / applications. So I'm going to do something that represents everything on the test, but even though it says y of x sine x at x equals pi, for this one, this is definitely a little bit more difficult than the one you get, but the idea of the tangent line lesson will still apply. So these questions are a little bit harder probably than or extra compared to the ones you get on your test, but I still will use them as a good example. So let's do the first one. Find the slope of the tangent line y equals x sine x at x equals pi. Now when I look for a tangent line, so this should look something like this or something. When I look for a tangent line, that is just simply a line that hits at that exact point. And I want a slope at that exact point. Well, what's a slope at exactly one point? It turns out the slope of exactly one point is simply a derivative. So, because it's just a derivative, what I can do is just find a derivative of this. So let's find the derivative, or y prime, or the dy dx, of this thing. So to derive this, this is technically a product rule where this is f and this is g. So we usually do g f prime plus f g prime. So g sine of x times f prime. Now f prime of x is just 1, so I'll put 1 here, plus f, which is just x, times g prime. The prime of sine is cosine x. Okay? Clean that up a little bit. Sine x plus x cosine x. I'm recording something. So then, in this situation, now I have my derivative. I just could plug in pi. So I could just plug in pi into this. So sine pi plus pi times cosine pi. Well, sine pi, remember on the unit circle, it'll be this direction. So sine is usually our y value, so sine is 0 here, plus pi times the cosine of pi, which is still over here, is -1, so -1. So your final answer is -1 pi. Again, I'm making this a little tougher in the review. You're not going to necessarily need to remember all the pi's or all the parts of the unit circle. At least make sure you know like 0, 90, 180, 270, and 360 degrees. Or in pi, 0, pi over 2, pi, 3 pi over 2, or 2 pi. Okay. All right, for this one, this is basically the summary of all these type of questions. Now, I'm not going to give you all 5 parts on the test. I'm probably going to pick like 3 of these out of the 5. So with that in mind, we're going to do this and talk about it. So, first one, let's talk about finding the velocity. Now, if this is the position function right here, the velocity function will be what's left over. So with that in mind, the velocity function is going to be the derivative of the position function. So that's v of t. The derivative of this is each one is individual. 4t to the third minus 9t to the second plus 10t minus 2. So if I ask you for just the function of the velocity, you would just need to do that. You would derive it once. If I want the function of acceleration, I want to know how much my change of position is changing. That's going to be the derivative of my velocity, which gives me acceleration. So in this case, I would derive this one over here. So derive this again, 12t to the second minus 18t plus 10 minus 2 gets canceled out from the derivative. So that's my acceleration. Now C says for the average speed. Now you might want to think, oh, average speed, I see the word speed, that must be velocity. But since I'm asking for average speed, I'm basically asking for the slope between 0 and 1 from my position. The same way, like if you ask for the average speed of someone who ran, a mile in 20 minutes, you would say, oh, their average speed is 3 miles per hour. You would just extrapolate from that. Maybe they weren't running that constant 3 miles per hour throughout the whole thing. They probably sped up. In the middle, they're probably the fastest. At the end, they're probably the slowest. But overall, their average speed was 3 miles per hour. So here, what we're going to have to do is 1 minus 0. So it's the same as y over x, or rise over run. Not f. But s, or position, at 1, minus the position at 0. So in this case, it's going to be 1 over, I'm going to have to plug 1 into this equation here. That's going to be, I'll just put it in here, 1 minus 3 plus 5 minus 2 plus 1 minus, when I plug in 0 here, everything cancels out except the 1, so that'll just be 1. So 1 minus 3 is negative 2, plus 5 is 2, minus 2 is 0, plus 1 is 1. 1 minus 1 over 1, 0 over 1. So your velocity average was 0. Does that mean they didn't move throughout that time? No, that would just mean at some points they probably were going forward. At some points they were going back. Overall, they didn't make any distance between 0 and 1. For D, I want to figure out how fast they were going at exactly 1. So if I want to figure out how fast they're going at exactly 1, I'm going to plug it into my velocity equation. So my velocity at 1 is going to be 4 times 1 to the third power minus 9 times 1 to the second power plus 10 times 1 minus 2. 4 minus 9 plus 10 minus 2. 14 minus 11 is 3. So it's going 3, I guess, units per second. I didn't give units here, but it was moving at that moment 3 miles per hour, or whatever it might be. E is how much the particle is speeding up. So if we're talking about how much something is speeding up, that means that we're talking about its acceleration. So in this case, I'm going to plug in 12. I'm going to plug in T1 into the acceleration over here. So 12 times 1 squared minus 18 times 1 plus 10. So 12 minus 18 plus 10. So 22 minus 18 is 4. So it's going 4. If it was a unit, meter per second squared, this would be like meter per second. And then this would also be meter per second because we're talking about average speed. Okay, like I said on the actual test, I might give you all A, B, C, D, E. You'll probably just take like C or E or D and B or something like that. Not all of them. Okay, this one's interesting because this is actually pretty easy, but if you don't understand what's happening, you're not going to be able to get it. All right, so for this one, I'm going to give you a series of information here, whether in a table or just like this. And in that information, there's going to be enough information to solve everything. If in this review I forget to put enough information, I'll just add it on the test. I'll make sure there's enough information. Okay, if you notice in this one, h of x is f of x divided by g of x. When I actually type it on your test, it'll look nice. So f of x divided by g of x. Find h prime of x. Okay, how do I find h prime of x? Well, I know h prime of x should be the derivative of this quotient, which forces me to use the quotient rule. Oh, I made a mistake. This should be all 3. So let me put this here. So first we're going to do it with x, and then we'll do it with 3. So because it's a division, we're going to use the quotient rule to figure out what h prime should be. So to derive that, we're going to do the quotient rule. It's g f prime minus f g prime over g squared. I didn't write all the x's, but you can imagine all the x's being there. But remember, since I'm looking for h of 3, what I'm going to do is plug in the 3 in every x that's here. So this will be a 3, 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 and this will be a 3. So it's g of 3 times f prime of 3. Luckily up here, I have all my g's and f's of 3's. So normal g of 3 is 7, because this is 7, times f prime of 3, which is negative 2, minus f of 3, which is 10, times g prime of 3, which is 2, positive 2, over g squared. So g squared of g3, which is 7 squared. From here, now you just do some arithmetic. Negative 14 minus 20 over 49, negative 34. Oh, I thought I set it up so I could actually simplify. But 49 I almost did it correctly. But either way, negative 34 over 49, you can't simplify that, but that is your answer. For this one, g of x, f of x, these are our product. So since it's a product, we're going to use the product rule. So it's going to be g f prime plus f g prime. Remember, because this j of 3, I'm putting of 3 for everything here. So I know what g of 3 is, 7, times negative 2, plus f of 3 is 10, times g of 3, positive 2. So negative 14, which, I mean, since we did the quotient rule, I could actually just see it's going to be negative 14 plus 20, or 6. In this one, it is m of x equals f of g of x. So it's a chain rule. Remember, chain rule is the outside times, with the inside being intact, times the derivative of the inside. Now what's really important here, the 3 only shows up inside this g. And the 3 shows up here also, I should say. But it's not showing up in the f prime. So when I get g of 3, I realize that should be a 7. So I have f prime of 7, because g of 3 is 7, times g prime of 3. We know g prime of 3 is 2. Well, f prime of 7, luckily I put it here because I knew it was going to be necessary, is 4. So I can rewrite that as 4 times 2, which means my final answer is 8. So again, mathematically, this is not actually too bad, because you just, as soon as you figure out which number goes where, you're just doing simple arithmetic. But with that in mind, you need to know what you're doing. Otherwise, you will just be, it'll be totally lost. Okay. Next one, linearization. So find the linearization of f of x equals 7x cubed plus 1 at a equals 2. So this is the linearization formula. I want you to know the linearization formula is similar to if you had y minus y1 equals m x minus x1. The little difference is if I plus y1 on both sides, it would become y equals y1, so f of a, so what is y at that exact point, plus my slope, m, x minus x1, aka the point I'm actually plugging in, which is a in this case. So in this case, this linearization formula is exactly the same as making a line equation. So I need f of a, so f of 2. So I'll just do that here. F of 2 will equal 7 times 2 to the third power plus 1, which is 2 to the third power is 8. 7 times 8 is 56, plus 1, 57. Well, f prime of 2 is going to be the derivative of this thing, which is 21x to the second, with the plus 1 disappearing. So 21, 2 to the second, 21 times 4, 84. So since I found what they are at each 2, I could just plug it in. So 57 plus 84 times x minus, I know what my a value is, which is 2. Let's distribute that 84. 57 plus 84 times, I'm distributing. So 57 plus 84x minus 84 times 2, 168. 57 plus 168, or minus 168. So this is going to be 84x minus 111. Yep. And that is my linearization. Basically, this is another way you could get a tangent line. Linearization and tangent line goes hand in hand. Basics for the linearization question, just remember this equation. If you have this equation, you'll be able to do the linearization of it. All right, last one. Find the differential of f of x equals sine of x and evaluate if x is 0 and dx is 4. So in this case, f prime is the same thing as dy dx. So if I just want the dy by itself, so if I'm looking for the differential, that means I just want the dy by itself. So since I want that dy by itself, all I would do is multiply dx on both sides. So dy equals f prime of x dx, which means you're doing the normal derivative you've already been doing, like the normal derivatives you know how to do. You're just putting the dx on the other side. So let me rewrite this as y equals sine of x. Well, I want the derivative, so dy of dx equals cosine of x. Well, I want the dx over there, so dy equals cosine x dx. All right, with that in mind, I know what my x and dx is, because my x is 4, or 0, and my dx is 4. So I'm going to plug in a 0 here, and I'm going to make this into a 4. Cosine of 0, on the unit circle, it's over here. So that means, and cosine is the x value, so that's a 1. So 1 times 4 equals 4. So your final answer is 4. This differential part of the question is actually really easy to do. The only problem is if you don't know that you have to move the dx over, you're going to make that mistake, and you're going to lose a point for that. All right, that's all the word problems that weren't covered in the quizzes that we had. You can check out the old videos for that. You can use your old quizzes. Hopefully this helps you completely. Good luck on your test, and see you then.